LeetCode problem 14, longest common prefix. Hey everyone, this is Keystrokes. Welcome back to the channel. Today we'll solve problem number 14 from LeetCode, which is about the longest common prefix, and it's an easy problem from LeetCode. This is a common interview question asked by many FAANG companies, and we'll work on a solution in Java. So let's take a look at the problem statement. So we are given an array of strings, and our goal is to find the longest common prefix amongst all the strings. If there is no common prefix, or if the array is empty, we can just return an empty string as the response. So let's see what does common prefix exactly mean. In the first example of LeetCode, the array of strings are flower, flow, and flight. And we can see that all the three strings have FL as the longest prefix that's common amongst all the strings. So FL becomes our longest common prefix. Now in the second example, the list of strings is dog, race car, and car. And by looking at the first character itself, they don't match. So they don't have any common prefix, and hence the answer is an empty string. So let's see what conceptual knowledge you need to know before we can solve this problem. You need to know some basic programming concepts like loops and strings, because we'll be iterating on these strings. And then you'll need to know about arrays data structures, because that's how we get the input, and we need to know how to deal with arrays. Okay, so we'll brainstorm first, and then we'll get into coding. And before we jump into brainstorming, please don't forget to like and subscribe if you've been liking my LeetCode videos so far. You can show me your support by buying me some coffee, and I've just launched my first level of Patreon. And this Patreon has only limited spots and gives you some special early supporter perks. And of course, I'll give a shout out to all the early supporters who support me through Patreon. And by joining this level, you'll get an exclusive voting power and help me direct the course of this channel. Also, through this tier, you can also reach out to me and we can do live chats if you need any help with any interview questions or if you need any guidance in general. And this will definitely help me to keep making high quality content for everyone. Well, let's get into brainstorming now. Okay, so let's say our input was flower, flow, and flight, just like the LeetCode example. Then our indices for these words will be 0th index will be for flower, first index for flow, and the second index for flight. And similarly, for each character, we have index running from 0 up till 5. So we basically need to figure out the longest prefix, which in this case is clearly F and L. So we can simply pick one string, let's say flower, and then iterate through its character, which will be F will be the first character, and then we'll make sure that the other strings, which is at index 1 and 2, have the same character as we saw in the first string right here. And we can just keep doing that. So next character will be L, and we'll make sure that the other two strings have L as well. And then for the third character, O, we see that the string at index 1 has O, so that works, but the third string has I in its position, so this does not really work. And so that would mean all the characters right before this line represented the longest prefix for these strings. And that's basically the idea of the solution. But there are some interesting base cases that we need to talk about. So let me update this question. I basically swapped the first string and the second string. So flow is the first string and flower is the second string in the array. And let's say if the third string did not exist. So starting our iteration again, we pick the first string, which is flow in this case, and then we pick the first character of the string, which is F, and then we make sure that the other strings have F in this position. So for 1, we have F in this position, so this is good. Then for L, we again have L in the second string at the same position, so this is fine as well. Similarly, for O, it's at the position in the second string, so this is good, and so does W. Now, the first string does not have any more characters. That is, for index 4 and 5, there is nothing else in there. So flow itself becomes our longest common prefix for all of these strings in the array. Now let's say if the array was flower and flow. Now when we try to solve this problem, we pick flower as our base string. We start with the first character, which is F, which matches with the rest of the strings. Similarly for L, O, and the same for W. But now when we get to E, we realize that there are no more characters here. So if any of the remaining strings that we are comparing with, if its length is shorter than the longest prefix we've been seeing so far, then that shortest string itself becomes the longest prefix in our string array. So in summary, we'll pick the first string in the array as a base string, and we'll use that string to figure out our longest common prefix by making sure that the other strings have the same characters at the index that we are iterating on. So we'll have a loop that runs from 0 to the length of flower string, and the same loop will basically be keeping track of the index of our longest common prefix. Now inside this loop, we'll have another variable, let's say current character, and this can hold the individual characters that we're making sure that other strings have as well. Then we'll run another loop, let's say loop strs, which will basically run from 1, which is from here, until the length of the array, which will be array.length. And in this case, it will be from 1 to 2. Now inside this loop, we'll check for two things. The first thing will be to make sure that the characters in the other strings match this f. So for the first iteration, we'll make sure this f matches this f. For the second iteration, we'll match this f to this f, and so on. Then the second condition will make sure that we haven't run out of bounds for the current string that we're evaluating. So let's say if we were checking for this e character, so we have to detect that this string does not have any e character, and then halt our iterations. And then if any of these conditions match, then we basically return the substring. But there's another interesting corner case. Let's say if none of these strings existed, that is, there was only one string in the array, then this loop will basically never run, and we'll run this loop and will come out, and no substring will be returned. But in this case, we know that the substring should be the single string that we have in the array, which will be flower in this case. So if this return statement is not executed, we should make sure that we're returning the first string that we have in the array. This also takes care of the condition when the first string in the array is the shortest string amongst all the strings, because then this iteration will stop early on, and then again this return statement won't be executed. Okay, so I think we talked about several corner cases. Let's code this out, and I hope that will make much more sense then. So this is the pseudocode for the solution that we'll code out, and this is based on the brainstorming that we just did. So let's just go through it. So we get an input array, which is a list of strings. Then we have a base case. If the input is null or empty, then we return an empty string as the response. Otherwise, we start a loop from 0 until the length of the first string. We can really choose any string in the array, but it's safe to choose the first string because we've already checked that the array is not empty. That means it at least has one element in the array. So in the next step, we assign a new variable called current character, which is the character at the current max position for the first string. That is, we are basically going character by character for the first string in this loop. And then we start a second loop where we iterate through all the other strings we have in the array. That is, starting from the first index until the end of the strings array. And here we can see two conditions. If either of these conditions match, then we return the substring. So let's see what the conditions are. So if the current length of the string is smaller than the current max, that is, if we found a string which is shorter than our current string, then that would be our longest common prefix. Otherwise, if the current character in the string that we're evaluating, it does not match the current character of the first string, then basically that's where our longest common prefix ends. And so we should just return whatever substring we have so far. And if you look at the return value, it's basically returning the substring of the first string, which is at 0th index. And for that string, the substring starts from index 0, that is the first character, and goes all the way until current max -1. And if we reach to the end of this statement, then either of two things must have happened. Either there was only one string in the whole array, and if you have only one string, then that is the longest common prefix because there is no other string to compare to. Or the first string was common to all the other strings. That is, the first string was the shortest string, and that itself was the common prefix. Okay, let's code the solution and submit to LeetCode. Okay, so here I have IntelliJ, and I have two classes, main and solution. Main has the examples that we saw on LeetCode, and the solution class looks like exactly how LeetCode provides it to us. And we can see that right here in LeetCode. They have a class solution, and they have this method, which is exactly what we have right here. We are just returning an empty string by default for now. So let's start by adding some base cases. If strs, which is the strings array, if it's null, or if the length of the array itself is 0, that is, it's an empty array, then in this case, the longest common prefix will be an empty string. Otherwise, we'll start a loop and we'll initialize the variable called max index, and this index will track where our longest substring ends. And we'll run this through the length of our first string, which is the 0th element and the length of it, and we increment this by 1 every time. Then we get the first character of the first string using max index, which we can store in current char and accessing the first string, which is at index 0, and then we ask for the character at index max index. Then we run another loop, and this time we iterate on all the remaining strings. So we can create a variable, let's say strings iterator, and initialize it to 1 because we already have string 0 being used here. So we start from the first string, and then we run this until the end of the array, which is strings.length, and then we increment this by 1 every time. Now, we talked about 2 conditions. The first condition is that max index is the same as the length of the current string. So the current string that we're operating on can be figured out by strings, then the iterator that we are running on it, and then the length of it. And if they're the same, then we can't have any longer prefix, and this becomes our answer. Otherwise, our second condition is if our current string, which is again pointed by strings and then using the iterator, and if the character pointed by the max index is not equal to the current character of the first string, which is string 0 that we calculated right here, then this basically means that there is a mismatch and that our longest substring ends right before this character. So in this case, we just return the substring that we found, which is the longest substring so far. And to find that substring, we take the first string that we've been using, and then we get a substring which starts from index 0 and goes up to max index -1. And we don't really put -1 here because that's how this substring method works. Now, if you go through this whole loop, and if this return statement doesn't go through, that is, if our first string itself is the longest common prefix, or if there's only one string in the array, then we just return the string itself, which is strings 0. So let's run it for our examples that we had in our main class and see if this works. So going back to the main class and running this program. Yeah, so it looks like all the examples were solved using this program. So let's go to LeetCode and submit the solution and see if this works. So copying this whole function and going to LeetCode and pasting it right in. Let's run it for the base cases. Looks like it worked for the flower base case, which we had in IntelliJ as well. And now let's submit this. And this got accepted as a good solution. We are faster than 93.47% of Java submissions, and the memory usage doesn't look too bad either. Well, that's all I had for this video. This was an easy problem, and I hope this video helped you how to solve it. If you like this video, then please don't forget to like and subscribe. And to further support me, you can follow me on Twitter or buy me some coffee and follow me on several other platforms. And the best way to support me right now is to join me on Patreon. I'm working on more videos and they'll be coming out soon. And as usual, thank you so much for joining in. Have a great day.